This is 4.1. So in this section, we are going to be simplifying square roots and doing some other things that are similar. So every once in a while, we'll have a square root that works. When we say works, we mean it comes out evenly. So the square root is asking what number times itself is 16, and the answer is 4. Right? But most of the time, when you take a square root, you don't get a whole number. For instance, the square root of 8. What times itself is 8? It's got to be some decimal. What's it going to be close to? Not 4. It's going to be bigger than 2, but it's going to be smaller than 3. How do I know it's smaller than 3? Well, what is 2 squared? So 2 squared is 4, and 3 squared is 9. So the answer has to be somewhere in between 2 and 9. And if you use your calculator, you get 2.82 something, 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 something. Right? But there is a way to simplify this. Now, how many different ways are there to write the fraction 1/2? So 1/2, what would another version be? 0.5. Uh-oh, he's on his phone again. He's not even paying attention to me. He is so in on his phone that he's not even listening. It's okay. First 2 are free. So I forgot what I was doing. Got thrown off. So 1/2. So that we could do the fraction 1/2. What else is equal to 1/2? 2/4, 3/6, 10/20. There are an infinite number of ways to write the fraction 1/2. Well, similarly, there is more than one way to write the square root of 8. And so we have developed a system for simplifying square roots. And as long as everybody follows the system, everybody will get the same answer in the end. Just like fractions, we don't want to leave 36/72 in that form. We simplify it down to 1/2. So what do? Well, we look inside 8 and we check to see if it has any perfect squares. What are the perfect squares? 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81, 100, and 121, and 144. And that list keeps going, right? Well, we are going to look inside 8, and we're going to remove any perfect squares. And the way that you were taught works, but I don't think you really understand how it works. What are 2 numbers that multiply to be 8? 4 and 2. Do any of those factor? 4 does, into 2 and 2. And then we scribble out anything that factored. So we're left with 2 times 2 times 2 is 8. Now, no matter how you factor 8, you're going to end up with 2 times 2 times 2. That is called its prime factorization. Every number has a unique prime factorization. Okay? And we look through that list and we check for... Uh-oh, she's on her phone too. But it's important. Really important. Got to order that cheeseburger. So, we look inside there and we look for pairs. Not the fruit, but sets of the same number. Do you see any pairs in that set? 2s. So I circle the 2s, and what do I do with them? For every set that I circle, I bring one of those out to the outside. So I bring out a 2, and the inside is everything that's left over, which is 2. So the simplified version of the square root of 8 is 2 root 2. Now, what did we really do? Okay. Well, I changed how the problem looked. It's still equal. If you write in your calculator, if you do the square root of 8 or you do 2 root 2, the decimals are going to be exactly the same. 2.82 or whatever that was. Okay? But mathematically, what happened? Well, I looked inside the number 8 and I found one of these numbers. Which of those numbers is a factor of 8? 4. So I could rewrite this as the square root of 4 times the square root of 2. Right? That's just the square root of 8. But the square root of 4 simplifies to be 2. So this turns into 2 root 2. Okay? Let's do the square root of 75. So that would be 5 and 15, 3 and 5. So the prime factorization of 75 is 3 times 5 times 5. Now I go through and I get rid of everything that factored. Do I have any pairs? I have a pair of 5s. And so for every pair I bring one out. 5 root, what did not come out? 3. 5 root 3. So the square root of 75 is exactly the same as 5 root 3. And the rules of, there are several rules that govern simplifying square roots, but one of them says you need to simplify the inside if possible. But are any of the perfect squares a factor of the original 75? Yes, 25. So I could have said that is equivalent to the square root of 25 times the square root of 3, and the square root of 25 is 5. 5 root 3. So there are two ways to do this. You can either factor it down and circle the pairs, or you can just look at a number and find its what square roots are inside of it. So let's do 48. The square root of 48. What goes into 48? 6 and 8, 3 and 2, and 8 is just 2 times 2 times 2. You could do 4 and 2. Do I have any pairs? So here are a set of 2s and here are a set of 2s. So what do I bring out? 2 times 2, which is 4. And what's left? A 3. Now, are any of these numbers a factor of 48? 16 is. So is 4. So this is the same as the square root of 16 times the square root of 3, which is 4 root 3. All right, let's do another one. What about the square root of 24? Does 24 have any factors that are perfect squares? 4. So the square root of 4 times the square root of 6, which is 2 root 6. Let's try it the other way. 6 and 4, 2 and 3, 2 and 2. Do I have any pairs? A set of 2s and a 6 left over. Okay. All right. Yes. Yes, the stuff that comes out goes in front. Yes, it does matter. Yes, money. Okay, what if we threw some variables in there? What if I said 72 x to the third y to the sixth? Well, we factor 72. 8 and 9. 8 is 2 times 2 times 2. And 3 times 3. And then x, 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 y, 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 y. What can I bring out? I can bring out a set of 2's and a set of 3's. So on the outside, I get 6. Can I bring out any x's? One set. Right? Can I bring out any y's? Oh, sorry. So x to the first. Can I bring out any y's? 1, 2, 3 sets with none left over. Does everybody understand that? So we can pull out a pair of anything. With 3 x's, I can bring out one pair, and then one stays behind. With the y's, I can bring out 3 pairs, and none of them stay behind. What if I had z to the 5th? How many z's can I bring out? 2 sets, and one gets left over. What do you do with the leftover? So y to the 3rd z squared. Does everybody agree with that? I bring out a 2 and a 3, a single x, 3 y's, and 2 z's. Then everything that did not come out just stays on the inside. So 2 stays on the inside, 1x stays on the inside, all of the y's came out, but 1z stayed on the inside. So that is the simplified version. All right, now I'm going to throw you a little bit of a curveball. What about this? How is this different? No. It's the 3. The 3. What does that mean? It's the cubed root. So what am I allowed to circle? Groups of 3. So 81 is 9 times 9, which is 3 times 3 times 3 times 3. And then 4 x's and 8 y's. What can I bring out? A single 3. One group is the same as is a single 3. A single x and 2 sets of y's. Everybody follow? Okay. What stays in? One of the 3's stayed. One of the x's. And then 2 y's. Okay. Everybody understand that? That takes us through most of the questions. Let's take a look at them. Okay, simplifying the square root. How would you do the square root of a fraction? You could, but what if it doesn't end up being a whole number? You take the square root of the top and the square root of the bottom. So the square root of the top in this case is 8, and the square root of the denominator is 9, so the answer here is just 8 over 9. Okay? Yeah. And your calculator, this one would work, but there are others that your calculator is going to give you a decimal. Okay? So we covered that. Here we're just going to plug in 1. We stick 1 in there and 1 in there, and I get 9 over. So it just says find g of 1. So put 1 everywhere you see an x. So 9 times 1 is 1. 6 times 1 is 6. Minus 11 is negative 5. So 9 over negative 5. Not bad. Okay. So here, the top and the bottom do not square root evenly. So I'm going to break them down. 5 has no factors, so we leave that. What goes into 45? 9 and 5, 3 and 3. Can I bring anything out? A 3. So on top, I have the square root of 5. And on bottom, I have what? 3 on the outside and a 5 left inside. Does that simplify? Yeah, those cancel. And I'm just left with 1/3. Right? What if I had the square root of 5 over 10? Can I take a 2 out of those? No. Outside the square root can only cancel outside the square root. Inside the square root can only cancel inside the square root. Okay. Okay, we can do that one. Well, let's look at this. What is the square root of 9w to the 4th going to be? Well, the square root of 9 is 3. Nothing left on the inside. How many w's can I bring out? 2. What's left on the inside? So if I have 3 times 3, w, I bring out a set of 3's, and I bring out 2 w's, what's left on the inside? Nothing. So the answer is just 3w squared, and technically there's a square root of 1, but we don't write it. So if everything comes out, the square root is not needed anymore. Okay. Here's the tricky problem. Oh, good job. So, one of the rules of square roots is do not leave a square root in the denominator. Yeah, that's one of the rules we have agreed upon. Just like don't leave a fraction unsimplified, with square roots, or any root, do not leave a root in the denominator. And the reason is, I can come up with one answer, and you can come up with a different answer, and they're actually equal. But yours might have a square root in the bottom, and mine doesn't. So what we have decided to do is adopt the rule that says never leave a square root in the denominator. Well, it's not 3.5. That would be 7 divided by 2. The square root of 7 is like 2.4, 2.6 or something. I don't know what it is. So here's how you get square roots out of the denominator. Now we call this rationalizing the denominator. So irrational numbers, square roots are irrational numbers. So we want to get rid of the irrational denominator. And the way to do it is multiply the bottom by itself. Now, if I multiply the bottom of a fraction by some random number, am I going to affect the value of the original number? Money? If I multiply the bottom by the square root of 7, do I change the original number? Yes. Right? If I just divide a number by 2, then it changes its value. Right? If I multiply it by 6, it changes its value. Is there a number I can multiply by without changing a number's value? What is the only number you can multiply by and not change the original? 1. So how do I turn divide by the square root of 7 into the number 1? I put the square root of 7 on the top as well. What is the square root of 7 times the square root of 7? What is the square root of 7 divided by the square root of 7? 1. So all I'm doing here is multiplying by 1. But it's going to alter how the number looks. It won't change its value, but it'll be wearing a different outfit. So the bottom is the square root of 7 times the square root of 7, which is the square root of 49. Money, come on. You need to know how to do this. Hannah, quit distracting him. So, the square root of 7 times the square root of 7 is the square root of 49. What is the square root of 49? It's just 7. So, in the bottom, the square roots actually just kind of cancel themselves and we get the number 7. But on top, now I have 9 times the square root of 7. Okay. What if I had 2 over the square root of 5? How do I rationalize the denominator? Well, I have to multiply the bottom by the square root of 5. What does that do to the denominator? Just makes it 5. And I have to do the square root of 5 on top as well. And then we just get 2 times the square root of 5. Okay? But it does get a little bit harder. So what about this? The square root of 10 divided by the square root of 6. Okay, what do I need to do to the denominator? Times by the square root of 6. And the top also gets a square root of 6. So the bottom just becomes 6. What about the top? Let's actually do 3 root 10 just for fun. So how do you multiply square roots? You do outside times outside and inside times inside. You could, but I didn't want to. So what is outside times outside in this case? 3. And what is inside times inside? 60. Now we have to check, does 60 simplify? So we take the square root of 60. What goes into 60? 6 and 10, 2 and 3, 5 and 2. Can I circle anything? Set of 2's. What do I do with that 2? On the outside, I already have a number on the outside. So how does the 2 affect that 3? It either adds or multiplies. Good. Which one? Multiplies. So the outside becomes 6. What's on the inside? Everything that's left. 3 and a 5. So 3 times 5 is 15. Okay. Now, all of these have a 3, but remember, you cannot use something outside a square root to simplify the inside. I can cancel the 6's, and the answer is just the square root of 15. Yes, because it says simplify. So yeah, you need to. Okay, so Monty's got a really good question. If I have 3 root 10 over root 6, can I cancel those? No. Outside and inside don't mix. But, Monty, go ahead. I could take a 2 out of there, and then I get 3 root 5 over root 2, and that will make it easier. How do I finish this? I have to put root 2 in the bottom and root 2 in the top. Oh, that's a 3. Sorry, I did it wrong. That's a 3. We took out a 2. I'm sorry. Okay. So the top becomes 3 square root of 15, and the bottom becomes 3, and then those 3's cancel, and I get root 15. So good eye, Monty. You can simplify to begin with if they share a common factor. You are a genius. Okay, for this problem, all you have to do is plug in 6 and then simplify the fraction when you're done. What if you get something like 8 divided by 0? That is undefined, right? Why can you not divide by 0? So think about, if I cut 8 into 4 pieces, how big is each piece? Or sorry, if I cut 8 into 4-inch lengths, how many lengths would I have? 2, right? If I cut 8 inches into 2-inch lengths, how many lengths would I have? 4. What if I cut 8 into 1-inch lengths? Then I would have 8. What if I cut 8 into half-inch lengths? I'd have 16. What if I cut 8 into 1/10 inch lengths? I would have 80. Okay. What if I cut 8 into 0-inch lengths? How many pieces would I have? So here's what you do. You take 8 and you start chopping. After an hour or so, you stop chopping. How many pieces do you have? A lot, right? But how big is each piece? Bigger than 0. So I need to keep chopping, right? So I keep chopping for another hour. And I end up and I have 7 million pieces. But every piece is still bigger than 0, so I need to keep chopping. So if you were able to chop until every piece was 0, how many pieces would you have? An infinite number. Right? Right. So will you ever reach infinity? No. Will you ever have pieces of length 0? No. So that's why you cannot divide by 0. Now, 8 divided by 0 is practically infinity, but we're never going to get there. And your middle school teachers were too lazy to teach you that, and so they just said, call it undefined, and then we're done. Now, here's another idea. What is 8 divided by infinity? So that means if I take 8 inches and I cut it into an infinite number of pieces, how long is each piece? 0. If you take 8 inches and you cut it an infinite number of times, then each piece will be length 0. Right? If you never stop chopping, those pieces are going to get smaller and smaller and smaller, which makes sense. So look at this. If 8 divided by 4 is 2, then 8 divided by 2 is 4, right? That's how division works. So if 8 divided by infinity is 0, then 8 divided by 0 must be infinity. So in calculus, you do that kind of division just about every day. You divide by 0 or you divide by infinity all the time. Yeah, it's easy. Anything divided by infinity is 0, right? No matter how long your yardstick is, if you chop it into an infinite number of pieces, which is not possible, but if you could, how big would each piece be? 0. So if you cut a log into pieces that have no length, how many chops will you have to make? An infinite number. You can't get there, that's right. But mathematically, this statement makes sense. Now, in the real world, it's impossible to do. But eventually, you're going to cut that paper so many times that it's just dust. And you just quit caring, right? Would you agree at some point you'd give up and you say, that's close enough? So that's what we mean when we say 8 divided by 0 is infinity, or 8 divided by infinity is 0. It means we do so much work that we just give up and say, never mind, I'm tired of this. They actually don't. Okay. Okay, we did that. We've done that. We've done that. We've done that. Okay, this is the only one we haven't done yet. So if I have 11 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many groups can I bring out? Group there and a group there. So on the outside, I write x squared. What's on the inside? Like that. Okay, that is 4.1. Get to work.